Okay. Yep. Looks like we're good to go. So let's go ahead and turn the icon off or whatever it is. So today I want to look at a response from AI to the rate of causation and see what its reaction is and see what we're up against as far as the scientific consensus, the scientific community as to the time light issue. Now, there's got some very interesting math. If you follow the math, so let's just go ahead and get right into it and see what he says. So we'll just add him to the stage here. Put myself over there. Here we go. Let's go see what Grok says. Okay, this part here is listed in the description. As to my questions, of course, I keep on. It takes forever for me to get my message across to what I'm actually saying or trying to say, and it takes a while for Grok to realize and understand what I'm saying. But I think he finally understood what I was saying, but it seems like, of course, Grok is always going to revert to the consensus, saying, well, that's not what the consensus, this is what the consensus says. Okay, so yeah, we know that. Okay, thank you for reiterating and refining your point with clarity. Hold on, let me fix this here a little bit. See if I can. There we go. There we go. All right. Thank you for reiterating and refining your point with clarity. You're emphasizing that more measurements due to shortened distance near massive objects makes things actually farther away, which is the observation. When we look toward a black hole, things appear to be stopped because the distance is more contracted, means it just makes every causation slower and time slows down. Plus time slows down besides the fact of the distance contractions. Okay. So I think I finally got it to understand what I was saying. Okay. Well, fewer measurements due to the expanded distance in voids with minimal gravity makes things actually closer in a physical sense. So the expanded measurements means there's less measurements, so it makes it closer. Makes things actually closer. Finally got that point across. They're actually closer. Okay. This suggests a fundamental redefinition of distance in my model, where the number of measurements, ruler length, directly affects the effective distance light travels, potentially compressing its travel time from distant galaxies, 13.8 billion years, to a much shorter period, like 6,000, as I've referenced. This aligns with your broader hypothesis. Gravity creates quantifiable spacetime, and in voids, faster time and stretch distance lead to near-instantaneous causation, explaining faster than expected motions like the spiral arms and Oumuamua's acceleration without dark matter and dark energy. And I've rejected flat space-time. This is Minkowski's flat space-time, which is incorporated into general relativity. So that, in other words, when in outer space they think, or they call it, flat space-time. So much so that if you remove all the matter, they assume that the manifold of space-time is still there. But my question is, when you remove all matter, then what there's nothing to cause space-time to exist. There's nothing to slow down time. There's nothing to contract distance. So how do you have space-time with no matter? Okay, I've rejected flat space-time, cosmic expansion, dark matter, and dark energy. Attributed redshift to gravitational effects, suggested black holes, pole space-time, noted electromagnetic effects. Okay, this is just mentioning a few things we discussed. Causing the void of space. So black holes seem to be accreting material, but as it accretes material, it probably accretes space-time as well. As a matter of fact, when it grows, it does accrete space-time, of course, because it's growing. So that, to me, is the reason for the vacuum of space, not any magical energy or invisible energy. Okay, and then there's a possibility of metallic hydrogen and such, causing electrical effects, which is they keep on talking about the electric universe. That might have some effect, according to Grok, not very much. Connected to void time dilation, but as long as they assume a manifold space-time, to me that's a big mistake, because the only thing that contracts distance and shortens time is the mass of matter, which is gravity. Without gravity, there's nothing to slow down time, nothing to contract distance. Okay, so back here, let's go to these plasma jets. I was aware that they were 7 times the speed of light, measured to be 7 times the speed of light, apparent velocity. Turns out it's 20 times the speed of light is the fastest superluminal motion ever measured. Of course, they've measured it with clouds, they've measured with plasma jets, and you have an emission right here of 20 C. So the plasma jets are measured to be moving 20 times the speed of light. Now that's a big problem. They try to explain it geometrically, and somehow, but this means that the light is arriving before it left. So I guess the light appears and then it backtracks or something. I mean, not sure how that's being measured or whatever, but they call it an optical illusion or a geometric thing. But I could see, maybe almost the speed of light or twice the speed of light, but not 20 times the speed of light. That to me is a big mismeasurement. And I believe that the reason probably is that there's a near-instantaneous causation in the void of space where there's no matter. Because nobody's ever been there to measure it, and I think it's a mistake to assume a flat space-time. But anyways, let's go ahead and go through this. It's a little bit difficult. Okay, so connected to void time dilation. Now, Grok can get it down to 2,000 or 27,600 years, which is not that far away from 6,000 years. The distance to Sagittarius A is about the same. So I'm guessing that somehow these measurements are off. They're not being measured correctly. Because this would be a problem here too. As far as timeline problem, I think this is even a harder problem than the most distant galaxy. Because Sagittarius A is said to be 25,000 to 28,000 light years away from us, which is not possible in a 6,000 year universe. To me, that would be even a harder problem because of the fact that distance contracts and becomes greater the closer you get to a black hole, except that I don't know how they're measuring. They're measuring this all the way to Sagittarius A. If they're measuring to the center, Sagittarius A, it's more like an infinite distance. But I'm guessing that if you measure to the outer rim where we can detect light, is probably only 6,000 light years away. But of course, they have bigger and brighter minds working on it. But even so, I think this is very, very close. Let's analyze your claim that more measurements make objects farther and fewer measurements make them closer, testing it against observations, use sources like whatever. Incorporate the current date. Current date. Okay, whatever. This is the other day, obviously. What is today? August 2nd. So this is the next day. More measurements farther and fewer measurements closer. You argue that shortened distance near matter requires more measurements, more ruler lengths. That's with shortened distance, right? So there's more ruler length between here and Sagittarius A than what we measure, making objects actually farther, while expanded distance in voids requires fewer measures, making objects actually closer, impacting light's travel time. So the farthest galaxy is actually closer than the center of Sagittarius A, which is said to be 26,000 miles away, or about 28,000 light years away. 1,000 miles, light years. Okay, the standard goes into the standard view, of course. This is the standard view. Distance and gravity. In general relativity, gravity contracts spatial distance near matter. Gravitational potential in a galaxy. The distance is this here, shorter than in a void. Okay. This is in a galaxy. Don't get confused. In a galaxy, it's that shorter than a void. In zero mass void, the distance is this larger, this amount larger. This is taking into account Minkowski's manifold of flat space. Okay. For example, 1 light year coordinate distance in a galaxy measures almost 1 light year. More ruler lengths needed. In a void, it's fewer ruler lengths. Now, it's easy to get these mixed up. I'm just hoping he's not getting mixed up. It's 1.00001. So in other words, they aren't considering it a big effect, whether it's in a galaxy or whether it's out of a galaxy. But with 20 measurements 20 times the speed of light, to me, it's a lot more significant than what they think it is. Okay, measurement distance, same thing. Okay. In voids, expanded distance means fewer measured. However, light travel times governed by spacetime metric, including time dilation, and remains finite. 7 years in void. Okay, 7 billion, 10 billion years for Z1 with 7 billion years in voids. Okay. But anyways, yeah, distance. This would be a distance, of course. And they're saying the difference is insignificant, basically. The effect on physical distance in standard cosmology, contracted distance near matter doesn't make objects physically farther. It alters geodesic paths. Oh, well, this is talking about basically gravitational lensing, I think. Expanded distance in voice slightly increases path length, not making objects closer. Well, yeah, because they're not factoring it in. Anyways, it's both in gravitational lensing. It's both a curvature of space, which is, I don't think that's significant, but it's also a slowing down of time and contracting of distance and making more measurements or having it pass through more measurements. That's what causes the lens effect. It's both not only the curvature of space, but it's also the slowing down of time and contracting of distance, which basically is the curvature of space. Anyway, so I don't know why they make a big difference out of that, but it does admit that it's both. Time and causation. In voids, 10 times. In voids, time is this much faster, which is insignificant. Okay, this doesn't compress travel time to 6,000 years. Okay, it's this here, years over 7 billion years. In other words, it's insignificant according to their calculations. Mine is more measurements and shortened distance near matter make objects actually farther, while fewer measurements and expanded distance in voids makes objects actually closer, compressing light's travel time to 6,000 years. More measurements farther near matter. Of course, they're saying it's insignificant. 1 light year coordinate distant requires a ruler's length, contracted rulers. So it's contracted rulers, so it needs a little bit extra from another ruler, which is right away saying that it's insignificant. However, this doesn't make objects actually farther in a cosmological sense. It's a local metric effect. No, it's locally where it doesn't make much difference. Locally, it's not going to make much difference. From here to the moon or from here to the sun, it's not going to make much difference. It's when you go from here to outside of the galaxy, that's when it starts making a big difference. Okay, light's travel time increases slightly due to time dilation, superior delay, not distance expansion. Well, because they're not considering it. Yeah, this is supposed to be my hypothesis, but he's got he inserts in here what it's supposed to be, according to the consensus. Okay, not distance expansion. Well, he's not even considering the distance expansion, not even considering, for example, lensing near galaxy shifts apparent positions but aligns with measured distances. Apparent positions but aligns with, well, that's the curvature. It shifts apparent positions, and that's the curvature of space. But it's not only shifting the apparent position, it's contracting the distance and it's slowing down time, which I don't think they're even taking into consideration. Okay. Fewer measurements closer. Okay. You argue it makes objects closer, implying reduced effective distance or travel time for a 7 billion light year void path. Standard expansion is such, slightly increasing travel time. So it's only a minor effect. To compress 10 billion years to 3 point whatever to 6,000 years, time dilation requires this, implying this. Unphysical for voids. In other words, he's saying it's not physically possible. Altering and reducing the effect of distance, 7 billion light years to 6,000 years, contradicts measured distances via supernova, novae, or redshift. According to their journals and their calculation. Minimal space-time, your view that space-time depends on matter with voids having expanded distance, fewer measurement, implies extreme effects, observed finite light travel times in near-flat void metrics. Now, he's still trying to hold on to the void metric thing, which makes a big difference. Because he's assuming that without matter, that there's still a time and distance platform, or manifold, as they call it. So the assumption is that the manifold is flat. And that's where I think the problem is. Because it is an assumption. More measurements near matter, shorten distance, and fewer measurements near voids, expanded distance, don't make objects physically farther or closer enough to compress light travel times to 6,000 years. Finite travel times, 10 billion years for Z to 1 can contradict your model. Okay. Now, implication for your broader model. Okay, I argue that matter's gravity creates time, space-time. Okay, this is a novel idea, that it's matter's gravity that creates space-time. And the void's minimal gravity have faster time, stretch distances, explaining motions without dark matter and dark energy. No flat space-time. Minimal space-time in voids allows propagation, but finite travel times contradict drastic time compression. Okay. Well, if time's running by faster, like many, many times faster, okay, it's going to rise sooner than the billions of years. Okay, no dark matter, rotation curves, and he's saying it needs dark matter or Mond. Now it's saying here that, you know, modified modified Newtonian dynamics. It's saying this is a legitimate idea, and this is a legitimate idea, but what I'm saying is not a legitimate idea. It says the void effects are too small, but it's not actually considering the dynamic of near infinite time and near infinite distance. Okay, void time is faster. It doesn't compress 10 billion years to 6,000. Okay, here we go. Void time dilation to 6,000 years and the Sagittarius distance. Okay. Analysis. This is, I think, maybe this is where it's getting down to. Zero mass void time dilation is this over 13.8 billion years is 4.6 times larger than 6,000 years. So even with a zero mass and void time dilation, well, it's still, I still don't think that he's considering the whole thing, because I explained that a galaxy, the stars you see from the galaxy, is not from the center of the galaxy, it's from the stars on the outer edges of the galaxy that we see, which are already in or near outer space, the void of outer space. So that has to be taken into account as well. But I still think it's not that far away. From 27,000 years to 6,000 years is not that much difference. And of course, we have the distance, and unrelated to Sagittarius A spatial distance, but I just think it's interesting that it's a similar distance, or light years. So the main thing is that it is not as bad as I thought, because to get 13.8 billion years down to 27,600 years, to me, is within reach of 6,000 years. And it's something we can work with. Okay, of course, it is unrelated to Sagittarius A spatial distance, but that wasn't what I was thinking. So compressing 13.8 billion years to 6,000 years requires unphysical gravity. But to me, it's pretty close, especially when I don't think they're considering the changes in both time and distance. But the main thing, the main point, the takeaway here is that that's pretty close. That number there is pretty close to this number here. So it's not as bad as what I was thinking it could be. At any rate, there you have it. That's the effect or the problem with the time-light problem. But you don't need dark matter. You won't need dark matter. You don't need dark energy because the universe is not expanding. Unless there's a reason for it to be expanding, it's not expanding. And there's no reason that the universe should be expanding. Now they think it's because of the Big Bang, and it's still expanding from the Big Bang, but then now they're saying that it's slowing down. They're saying the acceleration is slowing down. So they're always changing their mind anyways. But probably it's not expanding, since there's no reason for the universe to be expanding anyways. Now, what my idea is that it's the distance between galaxies that's expanded, meaning they're less distant, and meaning time passes by faster, so causation is faster, allowing for light to reach us. Now they're attributing the acceleration of Oumuamua to outgassing, which I suppose could be possible. I was suggesting that it was because of this causation effect. The rate of causation is faster away from gravitational sources. Now it's saying, of course, is void effect is negligible. The acceleration is negligible for the observation. They're saying that outgassing explains it, which I guess it's possible that outgassing might explain the difference. But in interstellar space or between galaxies, it seems clear to me that the rate of causation has a big effect and a big reason why it's possible to see light from distant galaxies, even redshifted. Because even redshifted light from distant galaxies is closer to us than our own Sagittarius Milky Way center, which is, effectively an infinite distance, but it's not. They don't measure it that way. They measure the size of a black hole, and they measure around the black hole, but they don't measure across a black hole, because the distance across is nonsensical, because it's basically an infinite distance to the center. So that the truth is that the radius of a black hole is greater than the circumference of the black hole. That's the nature of the black hole, is that the radius is an infinite distance, but that's nonsensical. So they don't even use that measurement. And they don't measure across the center of a black hole because of its nonsensical infinite measurement. But it is what it is, you know. The radius of a black hole is greater than its circumference. So they measure around the black hole. They don't measure across the center of a black hole because it's nonsensical to them. But the fact remains is that the most distant redshifted galaxy detected by JWST is actually closer to us than the center of our own Milky Way black hole. So the conclusion: more measurements in shortened distance near matter and fewer measurements in expanded distance in void don't compress light travel time to 6,000 years. It pretty much does, actually. Finite travel times, 10 billion years, and standard distance measurements contradict the model. Well, by your measurements, yeah, but not by the possible measurements determined by general relativity or the gravity without flat time manifold, without that flat time Minkowski manifold. It says a new theory is needed. A new theory is needed to refine the measurement as you propose. If you have equations for measurements or causation, I can calculate them. Well, I was going by the wrong one anyways. More measurements to, okay. Yeah. All right. This is basically going through the same thing. But yeah, I'm saying more measures make it longer for light to travel. Less measurements means light arrives sooner. But it's still going to say the same thing. Still going to say the same thing. Conclusion: more measurements near matter, shortened distance, and fewer measurements in void don't significantly increase or decrease light's travel time. Well, actually, they do. Okay. Zero mass void time dilation is 27,600 years over 13 billion years is 4.6 times larger than 6,000. But to me, that's an encouragement right there. That's makes it within reach. Okay, and of course, it's unrelated to Sagittarius A, which I wasn't trying to say it was related. I just thought it was curious that it's about the same distance. Because the distance it's not only the distant starlight that is significant, it's the distance to Sagittarius A that needs to be 6,000 years as well. So I'm not sure how they're measuring it to Sagittarius A, but if they measure it to the outer edges of Sagittarius A, depending on how it's measured, maybe it could be 6,000 years. But to me, that's more important than this number out here. To contract 13.8 billion years. Because both need to be taken into consideration, of course. Okay, it affects spiral arms, plasma jets, 20 times the speed of light. But it says the way they calculate it is negligible, but the way I'm thinking it should be calculated without Minkowski's flat space, it makes a lot more sense to me. Okay. But at least they do admit there is an effect. More measurements near matter, shorten distance, and fewer measurements in void, expand distance, don't significantly alter light's travel time to compress it to 6,000 years. Finite travel times and standard distance measurements contradict the model. New theories needed to redefine how measurements affect travel. No, all you got to do is get rid of Minkowski's flat space. But no matter how many times you feed the information, it's always going to feed the same thing back. It's always going to feed this consensus estimates and calculations back. Because it's not, of course, it's not going to consider the possibility of the rate of causation making a big difference without gravity between galaxies. Because there's nothing between here. The majority of the distance that light travels is in the void of space. Now, it was saying something like 70%, but no, it's not 70%. It's more like 95% of the distance is in the void of space. Because it calculated the amount of matter of galaxies compared to the amount of matter of the void of space. And it had it like 70%, but that's not how you calculate it. You calculate it from the stars that you can see around the edges of the galaxy to where we are, which is not in the middle of a galaxy. So there's had a false assumption there. But anyways, if anybody's interested or anybody wants to know, that's what we're up against as far as the time-light problem. Now, there's the thing, the one-way speed of light, which to me is kind of nonsensical because it's either instantaneous or not. And why would it be one way? You can do experiments with mirrors on the moon or reflections of the moon and stuff. Why would it have to be one-way speed of light? It doesn't make sense to me. Well, anyways, I guess there's many possibilities. There's maybe some more ideas out there too, as well as how it could have happened. But it was a creation. The thing to note that creation was a creation, which includes light. So as soon as the heavens and earth are created, then you have mass and matter and time and distance. But you can't have time and distance unless you have the creation of matter. So it was with the creation of matter, of the heavens and the earth, that we have time and distance, because that's what causes time and distance. And the the assumption of a manifold, or Minkowski's flat space, is not supported by anything. It's not supported by anything, because if you take away the matter, or absent matter, the manifold of time and space is assumed to remain. But how can you have time and space with no matter? It's just, what's the cause? What's the cause for the time and space? There is no cause. The only cause for time and space, quantifiable, measurable time and space, is the mass of matter. That's the only reason that we have time and space, is because of the mass of matter. There's no manifold. What manifold? From what power? From what? There is no cause for a manifold of time and distance without matter and mass. Otherwise, it's a magical time and it's not scientific. Minkowski's flat space is not scientific because it doesn't have a cause. And Grok agreed, it doesn't have a cause. It doesn't have a reason to exist. But that's what their assumption is. That's all this math that they're doing. All this math is based on that assumption. It's all based on the assumption of a manifold of flat space in outer space. And that's what has no scientific basis. So the Minkowski's flat space has no scientific basis. And if you understood that, then you could see how time and distance changes depending on the amount of gravity. Then you could see why there's superluminal motions 20 times the speed of light. It explains, and you could use the superluminal motion to calibrate the measures of time and distance, or better calibrate the measures of time and distance. So I'm pretty much encouraged by that. Even though Grok says this number here is not the same as this number, it's still not that far away. And I think we can work with that. We can work with that. It's 4.6 times larger than 6,000 years. Yeah, it don't matter. I'm pretty sure we can work with it, because I know he's not considering the true effect of the change in the rate of causation, or the possible change in the rate of causation. And I don't think it's a problem, as long as you understand that things happen faster without gravity. But that's about it. I guess I've exhausted it pretty much. If anybody has any comments or thoughts, you can add them, no problem. So, but that's about where we are, I think, as far as that goes. Hello, Dana. How you doing? Yep. Yeah, it's not everybody's favorite discussion, I don't think. I like to listen. Yep. Well, I think it's interesting. This and many other topics we get into, the genetic information, the breaking up of the continents. I think it's all very interesting. But thanks, everybody, for your participation. And let's see what we got here. Okay. And everybody take care and God bless. Have a great weekend and a great week next week. God bless everybody.